Star plots. What do we do with 2 dimensions? Here is my introduction. We used to try and build them. I'm just going to go faster. So if I have 2 dimensions, I have points like that. I put the axis like that. What happens if I have 3 dimensions? We just saw an example. So we have the axis like these. What do I do with 4 dimensions? Well, if you haven't guessed it, here's I can put 4 axes. Just like that. Now it's no longer three. How am I going to represent points? In the old version, if I had 2 dimensions, I have a point here. It meant it corresponded to some number here. So let's say this was 3 and this was 1. So that's how I would do the points. In 3D, kind of the same thing. How do I do it in 4D? Well, I'm not going to draw the point anymore. All I'm going to do is say where it intersects. So let's say this it intersects at 1, this intersects at 3, this goes at 3 again, and then this goes to 1. So now my point is really showing by a line like this. And that's the basics of a star plot. Sometimes they're called radar plots. And they have there's some variations. There's some variations on these. But that's kind of the idea. Now, on the old one here, if I had a second point, I would just draw it, and they will show up here somewhere. On the star plots, normally you don't draw a second one. You kind of leave it just one at a time. You could probably fit a second one and a third one, but after that, you have too many lines intersecting all over the place. So it's just going to be really hard to follow. You end up having a hairball. So traditionally, these star plots, they just use one. So one data point. What if I have 2 data points? Well, I'm going to draw the axis again. Now, that's just me drawing with the mouse. It's not. It's going to be the same axis. Repeat it. And then I will show the next point. And what you're looking for is basically the overall view of the point. What does it look like? What shape does it have? And here are some examples. Again, this one doesn't really have the axis drawn. You can see they're missing. But they are labeled, and many times they have to have a label for you to kind of understand what they're representing. So this is a serial data set. And then for 100% brand, you can see how that looks like. So you can kind of guess that it has a lot of fiber because it goes down a lot, not a lot on the top area, and it may not be that clear also exactly which one is a little bit smaller. So I cannot see small differences, but I can see things that look about the same. So this one looks about the same as that one. I don't know. Everything else, not. Maybe these two are about the same. But that's kind of how you look like. How many dimensions can I deal with? Probably I can go. I don't know. I have one that's coming maybe with a little bit more dimension, but I would say 20 dimensions, you kind of start running out of angles on the circle there. How many data points? Well, quite a lot, but you're going to have each data point tends to have its own. If you go back to Tufte, its own visualization almost. So it's a small multiples kind of. So if I have 100 data points, I'll have 100 of these. Probably need something. You won't be able to fit all of them on the screen. You have to do some scroll line or something after you run out of space. So in this case, how many do I have? 2, 4, 5 by 3. It's only about 15 points, and they take out the space. So maybe I can squeeze in another 30, and then they start to get really small, and I'm running out of real estate. So it's not a lot I can do in there. Here's another example. Cars. So these are the dimensions. I have this one because it shows the actual axis. So here is reputation in 78, reputation in 77. You can tell it's a really new data set. Turn ratio, G ratio, I think that may be acceleration. Displacement, so how wide they are, how long they are, weight, trunk space, rear seat, headroom, miles per gallon, and price. Oh, displacement, this may be engine. How big the engine is. Okay, so those are the dimensions, and here are a number of cars. And again, it's more obvious here that there are kind of classes of cars. There's these two here, and even this area. I don't know exactly what they are. Here is Toyota Corolla and Honda Accord. They look pretty similar in characteristics. They're cheap with small engines and small cars at the time. This is 70s, remember. I think these are more muscle cars at the bottom. And then there are some other cars up here that look similar. So this is how you can, this can be a Volkswagen and a Subaru, I think, the first two. But you can see that they start to look slightly different. How many data dimensions do I have here? I don't know, 1, 2, 3, 4 times 4, about 16 of them. Maybe a little, maybe I miscounted. 3 times 4, about 12. 12 data dimensions. Like I said, about 20 starts to get all not looking so good. How many different data points can I put in here? I mean, if you think about what else did we cover? We looked at linked histogram. How many data points? Can definitely do more data points, more cars in there than in here. Can probably do hundreds in there. Over here, if I put 100 cars in the same view, they're just not going to be distinguishable. Data dimensions, kind of, you like already said, I guess about 12. But the same thing will happen with the linked histogram. And if I put 10 data dimensions, 12, 20 data dimensions, I'm kind of running out of real estate there. With a scatter plot matrix, obviously, I can have hundreds of points, if not thousands, because they all go on the scatter plot. But the data dimensions grow really fast. If I put 12 there, it's going to be 12 by 12. That's 244 squares that I need to deal with. Over 100 scatter plots that I have to put in there. So keep that in mind kind of when you look at it. The other thing, just like there was the case for scatter plot matrices, on this one, I need to find a good order for the axis. Because here is what happens if the axis, if you look through here, they kind of, the reputation of a car tends to be about the same. So if I take one reputation and put it up, and let's say I take the weight, which tends to be correspond to the length of the car. The longer the car, the heavier it's probably going to be. But if I take the weight and flip it here, and then put the reputation down, what's going to happen, instead of having this nice, you can see cars with good reputation tend to have good reputation in both ears. Cars with lower reputations, they tend to stay like that. But if I take reputation here and move it down, and then move this up, my picture would look something like up and down, up and down, up and down. It looked like a star, like a burst. It really looks like a star, like a snowflake. Go up, go down, go up, go down. So if you don't have the right order, you're not going to see these nice patterns. They will all look like up, down, up, down, up, down. And yes, some of them may be rotated. So one of them is up and then down and then up and then down. The next one may be 3 degrees more to the right. But if you look at it, you're not going to be able to tell that much of a difference. Yes, it's rotated a little bit, but it's hard to detect that rotation. So order really matters. If you put dimensions that kind of behave together, if you know that, you put them. It's almost like you have to know how to build a visualization before you actually do it. Otherwise, everything looks like a jagged edge, more or less like here, like this area here. very jagged, up and down, up and down. Imagine having all of them looking like that if the order is not right. So that's one thing you have to consider. How do I place them in order? Another thing is that these star plots tend to waste space. Let's go back to this one. There's a lot of white space that is not being used here, and there's a lot of white space in the middle that has no meaning. In other words, what happens, my point is only one point on the axis, and then depending on where the next point is, let me change it. Since everything is red, I'll change to blue. Depending where the next point is, I may get some very skinny representation, because really the important part is just where it hits the axis. And whatever happens in between the axes is completely irrelevant for a star plot. So one idea was, one modification would be, what if we use the space between the axes to represent the data? So the axis, instead of being just one single line, think of it, the axis as being this whole wedge. So I'm taking it and I'm expanding it. And the line is really just a separation between the axes. So this can be x-axis, it can be y-axis, and so forth. So what you're going to have is that instead, I'm going to kind of cover the entire wedge, or just one point. And here's a representation. I think it's from NBA shooters. Again, you can see the axis is assists. It's this whole wedge. And then for each player, you can see how many assists they have. Like Larry Bird has more assists than Kawhi Leonard, because the axis, you can see, they fill out more of that wedge. So the axis, there are only 5 axes here, and it's really 5 of these wedges that become axes. So it becomes a lot clearer to see then. You can look at it, more of the color. The axis becomes larger, so I can see the point much better on that. That's pretty much the idea. Instead of having a lot of white space in between the axes is the space. And what I do is just color it. So you can see the average, top 5 average people, how they look like. And you can see, like Stephen Corey, how they're different from the other ones. It looks a little bit, to me, more, using more color. It's almost going against Tufte on this. I'm using more ink, but the data is clearer, because I don't have these white spaces that are kind of not useful at all. So that's one modification. So you kind of saw about 3 different variations of this. The axis being the entire white space, the wedge, have the axis shown, or have the axis not shown at all.